Hello everyone, welcome back. In this video, you're going to learn how to control access using RFID, like this. Okay, if you wonder what is happening, this card is authorized while this one is unauthorized. That's why with this card or this key, we can turn on the system, or if you want, turn it off. But when a user with a non-authorized card tries to control the access, that's enabling and disabling the system, this is what they get: an alert or an alarm to say someone with a wrong card is trying to access the system. Okay, let's program this. Let's learn to program this. Where do we start? Let's start by the introduction. Let's start by talking about RFID. What you need to do is to visit my GitHub account. Then you read the introduction. We're talking about the terminology. What's RFID? RFID is radio frequency identification. And what's a PICC? A PICC is this key or card. This can be referred to as a key or card, but it's called PICC to mean proximity integrated circuit card. What's PCD? That's the reader. It's also known as an interrogator. PCD means proximity coupling device. It couples the microcontroller and the card or the tag or the PICC. This stands between them. Okay, there is another term, MFR. That's the term encountered mostly when you're dealing with these cards. Or we don't know exactly where it's coming from. but what we know is the trademark of NXP semiconductors. Another term is to know if you're using an active tag. These cards are passive, but there are other cards that are passive or active if they carry a battery. Okay, this is how it works. The reader will just activate the card, send a signal, and the card will respond with data. Yeah, you can read this whole document if you want to understand everything or most of the things concerning RFID technology. Go and read this introduction. Okay, so we're done with the introduction. Let's now start wiring. This is the first wiring. Why this wiring? This is the basic wiring whereby we can read the tag. We want to first get the tag UID, unique ID, so that we may hard code it to allow it to access the system. Okay, or to authorize it, if I can say so. So this is the wiring. In this wiring, we have a number of 7 wires, whereby the VCC is connected to 3.3, ground is connected to the ground, SDA, which is chip selector, is connected to pin number 10. The serial clock is connected to pin number 13. MOSI, this is from the SPI communication protocol. I will make a separate video on SPI communication protocol, but MOSI means master route serial in. It means it's the signal coming from the master. The master in this case is the Arduino, to the slave, which is this card reader. MOSI means master route, slave in. Slave in. And there's MISO, which goes to pin 12. MISO means master in, slave out. It comes from the slave. It's only one signal that comes from the slave. Then there's also interrupt request, it's not connected, and then there is RST or reset. This is a signal that a master, in this case Arduino, sends to a interrogator or a reader. In the case it needs to reset data to a known starting point. Okay, this is it. So let's make sure this wiring is done. Fortunately, I did all this wiring. I followed that diagram already in order to save time. So we just do the wiring as it's on the diagram. Yeah. With this, even before adding the LED that will come in the next diagram, the next phase, for now, for the moment, ignore the LED, ignore the buzzer. They'll come in the next phase. So let's now get the code. Here is the code. This is the code for getting the card UID. Why do we need to get the card UID? Because we need to identify the card we want to authorize. Okay, so we copy it and we paste it here. We check, debug it, compile it very well, then we upload it. Okay, here is the code. When we open the serial monitor, and this is the card we want to authorize. This is the card we'd like to authorize. So when I put the card next to like 3 centimeters, let's go check the change. Yeah, it has found the ID. So let's copy this unique ID. We need to use it in the next code. Let's paste it somewhere. Then we can hard code it in the next code for access control. Let's do it this way. Okay, let's look at the wiring diagram. The wiring diagram says we need to add an LED. I added an LED at the pin number 2, digital pin number 2, and I added the buzzer at the digital pin number 3. Okay, they have their ground pins here. This is what I added, and then this is the code for access control. I select all and then copy. I go paste. I will make sure I copy this because it needs to be hard coded now. So I will check yeah, I will need to check if this is the ID, the UID I want, and when it's this ID, I will print authorized access. But when it's a different card, I will print access denied, and I will alert. Alert function was defined here, where I will use a buzzer. Allowing a system means turning on an LED, and when things go wrong, that's when a wrong card is detected. A buzzer will buzz in the style of alerting. The buzzer is supposed to beep once when the system works, either whenever the system works, that's turning on or turning off, whenever the access is being provided. Okay, this is the code. You can go through the whole code. It's self-explanatory. Well, yeah, let's compile it to see if there are errors. No errors now. Let's upload it. It's uploaded. Said okay, it's ready. And let's see what happens. By default, the system is on. And when I bring the authorized card in the proximity, the system turns off. And with the same card, whenever I want to turn it on, I bring the card or the key closer. It's on. But when an unauthorized card is brought closer to the reader, even when the system is off and someone is trying to put it on using the wrong card. Okay, that's it. I hope you enjoyed it. See you in the next videos, where I'll explain more about the communication protocol used in this program or in this project. Well, bye. See you.